Hey everyone, and welcome. Today, we're going to get into something that's, well, at the very heart of our super connected world. How do you find the absolute shortest path from point A to point B? Just think about it for a second. We all talk about degrees of separation, right? Like, how many friends of friends away are you from anyone? But have you ever wondered how a system actually calculates that? How do you find the fewest possible steps between two people in this gigantic, tangled web of a network? Now, if you're coming from a traditional SQL background, your first thought is probably self-joins. And you'd be right, but as you probably know, that gets painful fast. Finding a direct friend is easy. A friend of a friend? Okay, that's one join. But a friend of a friend of a friend? That's another join. And another. Each new hop you want to check just adds another layer of complexity, and these queries can get incredibly slow. Let's be honest, they just weren't designed for this kind of problem. And that really gets to a fundamental difference in thinking. See, relational databases are fantastic at storing things, entities like users or products. The connections between them, they're kind of secondary. But graph processing, it completely flips that on its head. It's built from the ground up with the idea that the relationships are the most important part of the data. In the world of graphs, connections aren't just an afterthought. They are first-class citizens. They're the main event. So to be super clear, what we're solving for here is the unweighted shortest path. That's a fancy way of saying we don't care about things like distance or time or cost. We just want the route with the fewest connections. Each one of those connections is what we call a hop. It's kind of like booking a flight, right? You're not looking for the cheapest or the fastest. You just want the one with the fewest layovers. That's what we're doing here. Okay, so we get the problem, and we know why our old database tools might not be the best fit. But how does a graph algorithm actually do it? How does it count the hops? Well, it's actually way more intuitive than you might think. Imagine you drop a pebble into a calm pond. The algorithm starts at a single point. Let's say that's you. The first ripple that spreads out, that's all your direct friends. They're just one hop away. Then the second ripple expands out from them, hitting all of their friends that you don't already know. Boom, that's 2 hops. The algorithm just keeps expanding this wave, layer by layer, until one of 2 things happens. It either hits the person you're looking for, or it maps out every single person you could possibly reach from where you started. Simple as that. And here is where the magic really happens. This is the beauty of using the right tool for the job. After all that logic, the expanding ripples, counting the hops, keeping track of who's been visited, how do you actually run this in a framework like Spark graphx? You do it with this. One simple line. You just give it the graph and tell it where to start. That's it. Now compare that elegance to trying to write a bunch of nested SQL joins. I mean, the difference is just night and day. And look at the output you get. It's just this beautifully simple map. Let's say our destination, our landmark, is vertex number 3. Well, the path to itself is, of course, 0 hops. We can see here that vertex 2 is a direct connection, so that's 1 hop away. And vertex 1, it looks like it has to go through vertex 2 to get there, so that's 2 hops. But what about vertices 4 and 5? Well, in this graph, they're like a separate island, completely disconnected, and the algorithm figures that out perfectly, telling us they're unreachable. So why should you care about all this? Well, this seemingly simple algorithm is the engine behind some seriously powerful systems you use every day. It's exactly how social networks figure out those degrees of separation we talked about earlier. It's how computer networks find the most efficient path for your data to travel by minimizing the number of server hops. And it's even a key part of recommendation engines, helping them find the closest, most relevant connections between you and a product you might actually love. Really, the biggest takeaway here is this. When your data is all about the connections, when the relationships are the most important part, then a graph-based approach isn't just another option. It's a fundamentally more natural and way more efficient way to find the answers you're looking for. It's all about matching the shape of your questions to the shape of your data. Which kind of leaves us with one final thought. If you started looking at your own data through this lens, through the lens of relationships, what amazing hidden paths might you uncover? If you found this useful, do us a favor and hit that like button, share it with a friend, and subscribe for more explainers just like this one. Thanks for watching.